As you have seen in the past chapters, implementing L4L7 devices is quite easy on ACI. As you may remember, in an on-prem environment, you have to configure access policies. In cloud-only mode, it is not necessary to execute this type of configuration. Now, let's get started configuring this type of components in Azure and AWS. Service graph is the mechanism that we're going to use to stitch external EPGs to the endpoint groups connecting the application. In this case, our app is going to be a web server. The integration is cloud native, leveraging all the functionalities cloud environments have to offer in regards policies and business continuity. If you desire, you can also automate the integration of third-party devices such as firewalls and service load balancers. Let's begin deploying our ALB on AWS. On the screen, you may see a small diagram with the names utilized along the configuration. First, we will create our Layer 4, Layer 7 device named ALB-Cloud-APIC. Next, we are going to create a service graph template, and there is where we are going to embed our ALB device. To finalize, we add a contract in between the external and application EPGs. With this element, we are allowing port 80 to reach the application and it to answer back to the consumer. Also, adding the listeners allows the ALB to understand what has to be done with the request. Let's get started with the first step. ALBs can be internal or internet-facing. In this case, we're going to use the second one, since we are going to request our web page from internet. After selecting the type of device, you must select the availability zones where you want these components to reside. When this configuration is finished, the ALB would be automatically spun. Before we start, I want to validate that no ALB is configured on AWS. Let's start configuring our device. We click Services, Actions, Create Device, set a name for the ALB. After that, we select the tenant that we previously created. Then, we add the availability zones where our ALB is going to be residing. In this case, we configure 2 availability zones to maintain a higher level of resiliency. Each zone has a different subnet configured on the berth. Now that both zones are configured, we click Save. Now let's go back to AWS console. Now there's an ALB pushed, and at the moment we do not have any targets since some configuration is still missing. For our second step, we're going to create a service graph and we're going to apply it. We have to drag and drop the load balancer icon onto the new service graph created and select your ALB created on step 1. We have to click the Let's Get Started button, set a name for our service graph. The tenant that you see below is the one that we already created. Then we drag and drop the ALB we created in steps before. The third step is to apply our service graph on top of a contract and add listeners to our ALB. These are forwarding rules the ALB interprets in order to forward traffic to the real servers. In our case, we will want the ALB to automatically forward traffic to all the servers in the web EPG. In order to do that, let's click on the Intent button, then EPG Communication, and I will select a contract I created before recording this video, which allows SSH and HTTP traffic. Then, I will select my consumer and provider EPGs. The consumer EPG will be the external one representing the internet, which in my case is called Web to Internet, and the provider will be the web server's EPG. Now, we will select our service graph from step 2, and as you can see, there is an error showing. This means that the configuration is incomplete. At this point, we need to configure listeners. In this case, we will create a listener rule that indicates that when the browser hits the index.html path, the ALB should forward traffic to the web server EPG members and will be listening on port 80. We'll now click Save. Now, let's see on AWS console what this configuration just pushed. Listeners now are being reflected on AWS, and now we can see that we have the targets. These are the real servers that we already have pre-configured. Now we can copy the URL in which the ALB is going to be responding to request, and if available, bring the content from the real servers. Now we go to our browser and paste the URL, and we can see how the ALB is listening and balancing across the real servers that are hosting our application. Thanks for watching. Please now join me in part 2 of this chapter, where I will show you how to configure the same scenario using Cloud ACI on Azure this time.